对啊，等一下我再看一下。
Good afternoon. So I guess we can start by talking about some announcement. Some of you actually emailed the TA saying that in the course outline, I explicitly said the group size has to be 4 to 6, and then also, but later I announced in the class also in the guideline that I allow you to individually, and some of you actually want to do individually. So I guess if you want, then we try to accommodate. Because usually I would recommend doing a group because of the workload that you're doing, right? Because one guy doing the whole project would be very demanding. But if you really want to do it, I don't want to stop you because but that's the case. But that would be you expect to sign up this, and later you tell me once you're done, then probably you can tell me your title that we will do at the I think on the second last class, right? I think it would be like according to the announcement, what we have is the I think 29th for this class, right? No, it's 20th. Okay, second to last class. So not sure where we're here or we will be up there, but we were doing this one on the 20th. Okay, so we're doing some presentation, and the presentation time will be proportional to the group member. So if you only one person group, then you only probably have a few minutes to talk about your result. Okay, so just make sure that you make it very concise. Okay. Is there any question before we proceed? No? Then we are going to continue our journey on lesson 5. So from now on, I think I hold your hand long enough on the Python, and probably we are not going to hold your hand too much from now on regarding Python. So I'm not going to run line by line unless necessary. I just describe the code and explain to you. I'm not going to run it. You want to do it, run it at your home. Unless there's some special reason, because of we want to speed up a little bit, because seems to be like I mean, I hold your hand enough. I think you're comfortable with Python. Copy and paste the code will be fine. Right? I'm no need to show it. But in case you really want me to show it, I can do it afterward, or sometime that I can do that. So I mean, this is the last time we focus on the multiple regression. We talk about it a little bit, but there's some remaining part is not done yet. But let us really go again into this multiple regression. As I said, this is the very first thing that is most important from this course is how to run multiple regression, right? And then later we talk about how to extend it to different machine learning method, right? But multiple regression remain the most important thing that you should learn. Otherwise, I mean, what you're learning from this class, right, is multiple regression and various machine method. And we will do horse racing between these multiple regression and other machine learning method, right? So that's why it's really important to understand the multiple regression result. So I'm not going to go line by line, but just mainly to remind you that once the model, right, we estimate that, you want to see the model is valid or not, right? So we'll do hypothesis testing to see the coefficient are valid. And also, we want to have, beside point estimate, right, we want to interval estimate for the coefficients. And also, when you predict, there will be prediction interval. So that is the main thing about that chapter. And afterward, we actually learn, basically, but pretty much stop there, is to how to run multiple regression. And again, the idea of multiple regression is similar to the simple linear regression, right? Instead of fitting a line, you're fitting a plane, right? If you have two variable, if you have more than that, you have hyperplane, right? But potentially just minimize the vertical distance, right? That's not very deep there. And of course, there's a formula, this is the equation, right? But at the end of the day, right, what we really do, right, in this context, we just stop there, right? It's in this thing, right? It's SMF, OAS, you write the formula, you write what into regress, you write whatever you like, right? And then we're done, right? So you can see it's not something super complicated, right? You can run regression as many or as less as you want to, right? And not going to bother you with all the calculation, right? And we also mentioned that we can do square, right? We can run this regression square, right? I think we just stop there when I run the code lab, right? I think just or you can do square. So we have that, right? So if we want square, then we just create another line, right? Say CPS. Let me run the code from the beginning of here, right? So I think we stop at the line. The code is like here. The data is here. So what you can do is run this to the downward. So I got runtime and run cell and below. Control F10. You will run everything from this one to the very end. Then what we want is to create a square. So that's what we have called H square, right? And then now you can do the H. Okay? Either you dot power 2 or you double dot square. Either of them would do. Okay. And then you can run the regression together. Okay. The way we collect the data will be using the star glazer. Okay. So we'll collect run the regression. Let's call the regression for to be this guy, but allow square term, right? I think this is what is there, H square. Okay. Let's run a little bit, let's wait a little bit, and we just run the star glazer. Maybe we really don't need that. We're just being lazy, just do this one. I'm done. Okay. So this is how you run multiple regression. You can add as many as you want. You create square term. Is that okay? So this is the only thing I add, right? Is to create square term. Okay. And I just run the regression. Okay. I just put together. So that's how you run as many you want, and you try to look for the star. If all the star there, then you're happy, right? Because the model is useful, and then you can start doing things. Is that okay? That's very standard technique there. I hope that is okay. So what I want is to continue. I think we do some kind of what we call interaction here, right? And the interaction here is what we're trying to do is to say, okay, we want to say that, say this wage growth depend on your man or female, also depend on age, right? But it's possible that actually age and female can affect each other, right? Maybe men grow wage faster, or movement can go, the wage can grow faster. So it really depends on this guy, right? So this is how wage change with the growth, how wage change with the female, but you can see interaction term, it's just multiply them. Okay. So because I want to see whether men and women can change at the same time. So you can run the regression like this. You can just multiply and interact, right? And then you will see, okay? And this line, what it's doing is actually the 5 and 6 is a particular way to subset the data is called query. It's same as LOC, focus on the female. So here what do is I focus on the case is female, and this I focus on the case is male, okay? And I run another regression that I intersect age and female, okay? So the first one is I limit the data set to female. And second one is I look at the male. And I want to see, okay, I separate two equations, or I run this, actually give the same result, okay? So that's why there's no need to restrict the data. You just add dummy variable, then you are done, right? So the result like this, I'm not going to run it because I guess we should save time, not copy and paste. You can see here, if you focus on women, this is the result, right? So basically, women each year, the wage go up by 0.6%. Okay? Men would go up by almost like almost like 1%, right? 0.1%, right? 1% there, right? And if you really add the female there would be something like this, right? So, but what do we have here, right? Is this coefficient plus this one should be this one, right? Because this is age, right? Female, then this is related, okay, in that sense, okay? But okay, so that would be the idea behind, okay? So you would run some regression there, and I think we talked about R square already, right? R square is the percentage that explain, but there is some issue of regression is because if you add more regressor, add more stuff, add more x, R square always increase. Okay, there's a math proof for that. Then it's hard to compare different regression, whether you add a square term, interaction term, is it better or worse, right? So I think you learn undergrad as well. Usually we don't look at R square, you look at R adjust, okay, which is very similar. But if the reason is if you have K is higher, this is larger, right? And in that case, that you actually punishing for having a lot of regressor, right? Because you have more X, then potentially can explain everything, right? So that's why you want to punish, have more K, okay? So R adjust is already in the regression table, right? If you remember, when we run regression test, adjust R square. If you report, I don't have that here. If you run the regression without using the, okay, there's a standard regression result, you have to adjust R square here, the second point. So R square is that number. So the problem with adjust R square can be negative, you can see, right? So it's not clear, it's no longer between 0 and 1, so it can be anything, but well, we still bigger and smaller can compare, okay? So adjust R square is still heavily used in choosing the right model. Suppose you have different model, who is right, who is wrong, how to determine the horse racing exercise is depend on adjust R square. Also, it's here, right? So you can see the adjust R square, right? In this case, R square same as adjust one variable. When you more actually is reduced, right? So then you will see this always increase, but this one need not, right? But this one already show you that if I decide based on adjust R square, I would do the third one, right? Because the third one actually a good improvement for R square. Okay. And the very last one, I think this is something very important, is what we call the y hat plot. Okay, plot. What is that? Is you plot the original data against your theta value. Okay, so if you are a perfect fit, then everything on diagonal, right? Because you predict perfectly. Okay, and anything that below that is underestimate. Anything that's above that is overestimate, right? Because the y is there, but you under or above, right? So look at this example, right? This is what you observe, right? And if the predictor is actually there, then that is the right thing. But you're below, then you under predict, right? Because it's supposed to be here, but you're there, right? So this is the graph. And how the plot y is actually very simple, right? But just quickly go over that. If you predict the value, right, and you do a scatter plot and log line, and then you just plot the line that based on the prediction, right? That is this 45-degree line, right? And that is what you get, right? Basically, you plot the scatter plot and the 45-degree line there, right? And then you will see this is the case, okay? I think it's good to go back to this hotel idea, right? We run this model, right? We have known this very well. I mean, in your assignment, you also run that, right? You see this. But now, then you try to explain the price by two things: whether distance from the center and how's the rating from the customer, right? The customer think it's good hotel, cheap hotel, or not so good hotel, all right? I mean, of course, you can add many things as well, but this is the simplest model. And if you look at this simple model, and if you want to buy a hotel, rent a hotel room that based on the distance and how good they are, right? This is something you care, right? And I think this is the same thing. I'm not going to talk about that. You just, right? Here, the only new thing is the rating. Okay, you run the regression, you predict that, then you just draw it, right? And this is the graph you see, okay? So here, probably we can look at the best deal because this is y hat plot, right? So this is the predict price, right? And this is the original one. Is it right? Should I put the right thing? Let me see. I should put y hat y. Okay, but I put the y hat y. Doesn't matter. I should plot the other one. I mean, let me do this one because I plot the wrong one, so I already plot the right one to make sure that's correct. So already have the data here. Just let me copy quickly. I'm sorry, I shouldn't do this part, but let me do this. Anyway, just maybe I should save time, right? Maybe that's okay. Let's run this part. So this is the data. Okay. And what I do is I try to, maybe I should use, I see, I remember. I should use this, not use the reader, but I use the Chrome. No, you don't allow me to use the Chrome to open it. I really hate doing that. Can I not do that? Anyway. Let's don't be lazy. Let's don't be lazy. Let's don't be lazy. Let's do it. Okay. Then I filter the data. And okay. That's how I filter the data. Okay. And then I would just using the random multiple regression, distance and rating. Okay. And I predict the price. So I hope that should be not take too much time. You run the regression. I think it's good to take the code again. So just run the regression there, the data from there, and I run it. The DF will be the enterprise. Okay. And Y hat will be the prediction based on the data because I use the SMF, so that's why I can use that directly. Let's see what is embedded there. Let me compare. Oh, I missed the dot fit. So this is the model. I run the regression, and then I just plot it. Okay. And what I want is I want the Y hat Y plot. So I just need to change the little bit. So I guess maybe right. Minimum the max. So minimum of the head. Okay. And the maximum. So I created what are the value is minimum to maximum. I have 100 data points. So basically I divide the Y hat into multiple points there. And I draw a scatter plot, which is based on Y hat Y. Okay. And I plot the line there. It's based on this. Okay. The line there. And this is predicted value. And this is the original price. Okay. So I think this is right. Yes. So I think this is right. Yes. Yeah, for the bracket here. And let's see, what did I miss? So there's a line there already. Okay. And this is the price and predicted price. And then in that case, then you look at the I want to plot the other way around. So maybe I just plot the other way around. I don't plot in this one, but rather I plot the Y hat Y. So I just do the same, but instead of Y hat Y, I have the Y hat Y hat. I also have this one, and this one I have the reverse. Okay. I run this one. So so this is another one, but I think use this one is a little bit better because this predict is our model, right? So this one means that if $80 and now it's sold at 80, then it's the fit the model. And if you look things below, they're actually cheaper than what it should be. So if you want to find a bargain, will be somewhere, look at this region, right? So these are all bottom of the good one. If you use this predict price over predict price, and if you use this one, that will be the same, but you are trying to look at this on this side. Okay, you predict at this price and actually saw at this price. So it depends on whether you're looking to look at the left-hand side or the bottom, because the same thing, right? Because these are saying that you predict this price, but you're selling much lower. So everything on the left of the right line, the red line is good. Okay, or you like that one. I don't know which one you like. I think the textbook used this one. It's called this Y hat graph, or sometimes Y hat Y, but this is how you look for the bargain, right? Because just to remind you, these guys are the good bargain, right? So this is something that you look at, right? And if above that, it's more expensive, okay? And this is the model that based on rating and price, right? Suppose you use the other thing, right? You also not care about distance and rating, but you also care about stars, right? Say if you want stars as well, you can add star, right? Say if you want to run that, there's also doable, and then you can also run it. That will give you something like that, similar, right? But something are different here, right? And then of course, before I run this, if this is your regression, then probably you want to look at the summary of the regression, right? Clean regret summary, right? There you tell you how well the regression is, right? And then you can see stars actually meaningful, right? So because 3-star hotel, 3.5 or 4-star are different, right? So it's a really predictive power. And you see the graph is slightly different, right? And now something was there, but now it's gone because this is the way it works, right? The more you add, then probably you explain more. Then you can add more things until you get things you like, right? So if you don't know what to add, right, just go back to here, look at the DF and head, right? Or look at the head, right, and see what kind of data you got still, right? There's a many thing there, right? I don't know whether you want what kind of variable you want to, right? But these are, you can look at check, rating count, how many rating you have, but you can add as many as you want to say, to make your model more useful. Is that okay? So, is that okay? So I don't want to, this is multiple regression. I think if you undergrad, you do a lot, right? So I'm not going to spend too much time on that. I think I want to spend a little bit time on our next lesson, lesson 6. Okay. So trying to, so because of the time, probably I would only cover the first part, and I will let the time series part uncovered because I don't think any one of you is doing financial data anyway. If you do, then probably you have to read that. But otherwise, I just skip because of the time. But that is, you can look at my slides, already tell you what to do. Okay, but in that case, I mean, but I think for IT person, I don't think you have to worry about that unless you're looking at very high frequency data. You averaging those, and you shouldn't be an issue there for you. Okay. But again, probability, I will be also very quick because I think that is not something too much different from what we have been doing. Okay. The reason that about probability is the only thing we said is why we don't have any restriction, right? Y can be anything, right? And now my Y is going to be 0 or 1, right? Sometimes Y is like whether the customer would buy your product, right? in that case, our y is only 0 or 1, right? And actually, you can still run regression. That's no problem, right? Because the data is just 0 or 1. There's no restriction on what you can do, okay? And in most cases, you run the regression as normal. There's no problem. You can still predict, okay? But the problem comes from interpretation. Because running regression, it is 0 to 1. You can predict negative probability or more than one probability. It's still fine, right? It become less meaningful, but you still have, say, if the predicted probability is 1 point something, that means that it's very likely, right? If negative probability you get, then it's still okay, right? Just like very unlikely, right? But that's why. But still, I mean, we want to have some good prediction, so that's why we will introduce what we call Logit and Probit model, okay, that restrict the things to 0 to 1, which we will see soon. But we will first argue that the probability model, the regression we have is still fine. Okay. So if binary data, yes, no question, we can still model as probability, right? And the probability is continues from 0 to 1, right? And then we can still run that, right? So this is the probability. The only data you have is 0 to 1. That is no problem. Okay. And you just still run the regression. Y on x1, x2, right? The only problem is the prediction. It's above 1 or below 0. Okay. And let me do the case study. As I said, because now we go to more complicated model. I mean, I don't want to run this code because if you try to see, if you go to the website of the publisher, you look at the code, cleaning data will take, I mean, at least 10 pages of slide because they didn't clean the data. Then it takes a very long time to clean data. So I don't want to spend time talking about how to clean up the data. I can share the code with you if you want to, but or you can go to the website directly. But what's the question is whether smoking, right, change your health, right? So whether they are going to be healthy or not, right? And the question will be looking at the people who smoke long enough, right? And look at them, they consider healthy themselves, and ask them 4 years later if you smoke actually would get you less healthy. Oh, this is a question, right? And the question is based on a European country, okay? They look at whether the guy stay healthy or not so healthy, just binary outcome, right? And they look at 14 country, look at 4 years data, and being healthy actually asking to say they feel good, they're excellent, right? And N is like 3,000, right? And probably if you want to do it, you can do a data on Thai, right? Because now many people drink Thai, and especially Thai coffee, right? Thai ice cream, right? Because last week, I mean, probably you know, I go to Macau and I go to one of the casino and noticed I didn't do gamble to be absolutely sure I didn't gamble anyway. But I look at how people gamble. But anyway, we'll talk about how people gamble later. But I saw people selling giving Thai ice cream. Okay, so that you may consider doing that. So anyway, here I want to run the regression, right? The simple one is to see whether it's healthy or not. CO1 is depend on the smoker or not, right? The smoker is also CO1, right? Both are just only CO1, right? So you can have a scatter plot like this, right? And this is smoker staying not so healthy is very small. And actually a bunch of people actually a non-smoker being still healthy, right? And this non-smoker being not so healthy. This is smoker is still healthy, right? So that is the idea. And then you can see this graph here. At least look at the average, right? It's here. The average is here. You can run this almost like stupid regression. You can plot like this way, all right? And seems to be smoking make you less healthy, all right? And that not surprising at all, right? So which here the data said 7% porn less likely to be healthy, right? Because the slope is like 7%, right? Because that is the regression tell us, right? 7% less healthy. Okay. So instead of this smoker, we want to control many things, right? Control where their condition, how old they are, how things being done, right? So well, one of the reasons why there are many studies that criticize people say drinking red wine make you live healthier, right? There's many studies, right? And then being criticized because of who drink red wine, right? Only people were upper middle class, right? I mean, people would drink beer, right? People would drink water, right? The white wine or other thing, right? So only people who really have a lot of money then will drink red wine, right? I mean, you have to appreciate the red wine, right? It's so complicated, right? So that is the idea, right? So it's unclear that if you don't control them, you don't really know, all right? So it's not so clear where what does that mean, right? So that's why in the regression you should pick many things, right? Where gender, age, education, income, how fat you are, body mass index, and so on and so forth, right? And think of functional form, right? And you run various regression, okay? And then you try to look at, say, how income, right, looks like, right? As you earn more, people actually more stay healthy without thinking about smoking. Education is a little bit surprising, okay? If you have some education, actually you're not so healthy, right? I don't know why, but when you have more, you go up, right? And who has 24 education, 24 years education? Maybe me, I guess, right? Ph.D. and then you go to here, right? So now you're at the good, you're now is here, okay? If you study more, then you will become here, okay? So hopefully you stop here. If you go like me, then will be go down, right? So it's very weird. But anyway, this is what data look. Remember, this European data, right? That makes sense because usually for European, I mean, doing PhD, usually you get a very low paying job. I mean, unfortunately, compared to people who compete with master. So that is the regression you have, right? And turn out that smoker control many things as well. Smoker actually makes 6%, so reduce. Sorry, still significant, 1 star there, right? So you look at other thing. Female actually is not significant. Whether you're female or not actually doesn't affect your healthy, right? Except because this is self-report, so maybe men are more confident, right? Even though I'm not healthy, I still say I'm healthy. So that happened, right? And age is negative as expected, right? And education, as we said, I mean, this is not significant, but if you go it before the master program, I guess, right? 1860, yeah, right. You've done the undergrad, right? So it's still better. And higher income, you're more healthy. The BMI, as we expect, right? Not so fat people is better, right? If you exercise a lot, that's the best, right? So look at all these things, right? Ask yourself what? From this example, don't smoke, exercise regularly, study until master, not too fat, earn more money, right? To stay healthy, right? And being a female is not being very useful. So there's no need to change your gender, right? At all. There's no point, right? And age doesn't really change, right? So that would be the result you can get from that. Okay. So that is negative 0.6, right? But now the interval, look at the 95%. That's you can use the Python to export that file. That means that this is the worst case scenario can be nothing, right? And the best case scenario can be very bad, right? So it really, but still is smoking is not going to be very healthy, right? But it's possible that actually they're 15, 16 years old and maybe they are not very healthy anyway, or they didn't aware of that. right? So that, although I don't know, or maybe Europe, you smoke doesn't really matter, or European doesn't smoke that much. I don't know. It's very hard to say. But that's the data, okay? And when you look at the prediction, it can look at the data, right? Here is, in general, it's between 0 to 1, but it can be go beyond 1 and go below 0. Of course, this graph doesn't show you, but there's a problem, right? So you give me a bunch of data, you can predict the guy is healthy or not. If it is, say, 1.10, right? That is a problem, right? So we say it's 1 or not 1, right? But at least it shows you something, right? So, but that would be the idea, okay? So that's why we would, if you learn from, remember undergrad, okay? We would consider the case instead of the predict the probability 0 to 1, we will consider what we call a link function, which we'll define later, okay? And the link function depends on whether it's logistic function or normal function. We determine what we call Logit or Probit, okay? Which I will define very soon, okay? So what is it is, instead of y equal to this beta 0 like this, okay? It's not a linear related. It's a function. It's called link function. It's a gamma. It's a big gamma, right? The big gamma function. The textbook, this big gamma function, right? Instead of y equal to this linear, right? But I said y is equal to this function, okay? And if you want this logistic, right? And that is called Logit, okay? And why would care about this Logit? Because this Logit, if you know math, this can be calculated explicit form. You can have a nice formula, okay? But we know that many often the time we think this is more like normal, it's better. That's called the Probit, okay? I'm not going to talk about that, but they are the two main methods when the y variable is 0, 1, okay? So I'm not going to run this model, but you can see I have multiple regression. X contain 2 variables here, right? And I can run a Logit and fit the model and print out the summary. Okay, you can run that. Okay, and when data is more complicated, you can run that as well. Okay, this is the model. You can see it's very similar to the OLS regression, but you can see we don't have R square, right? We don't have R square. But that being said, we have some what we call pseudo R square. Okay, the pseudo R square, as you can see, is a fake R square. Right? Pseudo is fake. So fake R square is again similar idea. So the pseudo R square is larger, the better. That would be something we look at. This is the thing that usually we would look at. Okay, so the bigger, the better fit. Okay, and of course you can also calculate the SSE, MSE, whatever. MSE can be done as well, right? Because you can always predict and look at the difference. That is doable, right? But anyway, when we compare different logic model, that we would use pseudo R square, right? Suppose this I use x1, x2. You may want to use x1 square or x2 times x1, this kind of any combination of that. Then how you compare different model, you do the horse racing based on pseudo R square, right? You pick the one that has best pseudo R square, right? Provided that they all, the p-value is useful, right? In this example, the p-value are crappy, right? This model is rubbish, but just example, right? So in general, this you can see that should be there, okay? And this is the way you run the Logit, right? So the only thing is that I use the that model again. Instead of OLS, I have the Logit, right? Okay. And one thing that I have to emphasize is the coefficient in the Logit and there's a problem about the interpretation about the coefficient. So this one, the coefficient is not very meaningful because nonlinear, right? Because the coefficient is remember, you're fitting this model, right? So what does that mean, the beta equal to that number? It's not very clear, right? So from calculus, you should take the derivative, right, of the y with respect to x, right? Say if you recall, right? If you remember this example, with y equal to alpha plus beta x plus, say, gamma x squared, right? So the coefficient of beta and gamma is less clear, right? Because you want to look at delta y, delta x, right? Which give you beta plus 2 gamma x, right? And then the question is asking is, when you change x by 1, how y changes? But that would depend on x, right? Then you have to tell me how you evaluate this one. And usually you evaluate the mean. You put mean of x there and put this number there. That will be what we call the marginal effect at the mean, right? Same actually goes on here, right? You can take a differentiation with respect to x, say. Then you have a complicated expression that will depend on x. Then you want to evaluate at the mean, right? We can evaluate at any value, but we can evaluate the mean. That is the usual thing we do. So that's why here we will do that is we will get margin, and at mean you can add any median or any quantile, that's fine, but we have mean, and then you can print out the summary and tell you that increase 1 unit in x, then what happened? dy dx, right? Input x1, that's what change, right? So that would be the marginal effect is something we care, okay? But again, as I said, in many applications as an IT manager, I think it's okay, you just run linear LPM model. Just run the simple regression the best. Okay, it always is the case, is like, although we have many techniques, turn out to be the simplest one actually the best. I think just like, right, they said, right, many Kung Fu technique, right? And what is most invincible is fast, right? 天下武功唯快不破, right? Is fastest is the most useful one, right? So the same idea, right? No matter what you do, right? Actually, OLS is one of the best thing you can do, right? Turn out to be, and the nicest, because you don't see actually prediction wise is not too much different. So that's why I just very quickly go over this Logit and Probit, because I think for our purpose it's not really that matter that much. But I just include them in case you actually learn it and then you don't know when y is 0 or 1, right? Then you can run Probit. Okay, here is like the Probit, the Logit and the Probit here. Okay. And you can see this is all pseudo R square, right? This is the thing, right? You would compare this one, right? You can see it's 0.3073. Then you do want to do horse race, compare this one. Then Logit pseudo R square less compared to Probit, right? So if you ask me which one to pick, I pick Probit, right? Of course, they're too small to be different, but if you have to choose one, then I have to choose Probit, right? And the question is, if you ask me to choose OLS and this one, I can't tell you right now. We'll tell you how to do, which one to pick later, right? But this is, we can ring a horse races between OLS and the Probit Logit, but that will be done later, okay? But we just keep this in mind. You R square or R square adjust is compare regression, right? If you compare Logit and Probit, you will be doing pseudo R square, okay? Then we'll do later horse race across different model we can do. But this pseudo R square is compared within the same type of model, or you have different specification, right? Say whether you keep x1 or take it out, then change pseudo R square, right? Then it will be something is in our mind. And I want to mention one thing that we're supposed to mention at the very end of our course. but we will know as well later is what if you have many columns, what you should do, right? What is to kick out, what is to keep. Okay, of course, later with machine learning, we tell you what to kick, what not to kick, right? But the thing is, if you have theory, you have some idea behind, then you should keep those, regardless of your star or not no star at all. So you shouldn't kick out the model, even though the regression, the p-value has no star, right? If the theory tell me that they are related, you just keep them. Just like the hotel model, right? The hotel price model here is, okay, even if the regression tell me that, okay, this value may not be less than 5%, okay, I will still keep them, right? If that is relevant from economics viewpoint, from business viewpoint, right? There's no need to take away the model, just keep it there, okay? So that would be the idea, okay? And okay, I will talk about pseudo R square after the break, okay? But I think I introduced the Probit and Logit, so you can just run it same as ORS, right? Because the only difference is this guy, right? Because if you ORS, there's ORS. You run Probit, there's a Probit. So there's nothing where we, in terms of Python, it's very simple. Just change a function, then you're done. Okay. So that's a break of 15 minutes, and we come back, and then we will talk about a little bit about pseudo R square, which we mentioned there, how to measure that. And also we have another measure called deviance, and also the mean square error. The mean square error is to do the horse racing, compare ORS, Logit, and Probit. Okay. So, and also talk about other two measures which we didn't mention. It's called AIC and BIC. And these are the things that we will use to look at when we compare different type of models. Okay, so let's take a break of 15 minutes, then we come back and finish the Probit and Logit different set of slides. Okay. And I have the overleaf so that you can tell me what's going on with you.
有没有还有这个我以前没有。
看那个看上去就不像你说这样。
那你之前的，那这个，光，这有点像那个什么非洲那个被遗忘。所以开始我给我自己取名叫，我有学生别人叫我在看，我在寝室看，别人叫我在同事，我就说我在同事，然后那个教练说，你这个名字太像女生了，然后就没有。我为什么变？我也没有变。对，我一般就是少的东西会比较对珍惜一点，自然比较少，有时候很特殊，但我不是，所以我这上面都很急了，我都看好久，没见。对，我很是地方。才让我这个我其实主要是我的舒服的，然后我刚不搞到这个，对，因为我把它这个我是不懒，我不是我没有说故意想别的问题，我就懒得写。对，我应该不会上面有一个，后面有一个，对，因为讲对啊，上个风格那意思。对对。对啊，都是，所以我才讲。那这个我没知道。我也在纠结要不要没错，但是到那个，啊，对，我在那个，就是我看以后也在那看，对，然后扣的是对的，我那边那个我报了，也看这个，那个上海对必须的水，对，我们可以3年水，有3年水，有3年水，对，我看你说在加一个，比如说有一个加过。就是首先就是刚才那个他的那个他就是上面的发言就是对，就是他不用这个他会放那个，对，对我看你的，我主要问题是我之前用 B.B.A 上的他是放那个放那个，就是我一直也放数字，然后我不可能改一下，然后就放个 mini 的。我当时还觉得自己很确实，那我确实对，没有，我在开玩笑。 我也在考虑这个，我在想要不要用它。这个听着上不一样。要不不配合的。结果呢？话说，那个对改就分开了。
那整整一个晚上。但是没上好到我肯定说不准看。没有，我给你看。我前刚完成了这个刘海。那个是
对，它3个。
这里就有B.B.A，反正的话，
这是对的吗？这个这样写的 OK 的吗？对，这是300和1个对吧？如果说3个，我不想要这个，我可不可以每个词都加一个这个 log？
可以啊。
我不知道这个漫画是干嘛。这漫画就是前面，它这个不就相当于是前面所有的。哦，这个漫画好像是那个意思。
厉害。
是不选的意思。就是它如果放在一个例子，就是那个海上面是
你就白的话呢，跟今天的风格有点相反，你黑的都白。他们跟你说今天的风格。
没上吧？
不同的感觉。
风格。
我这里感觉，感觉不同的感觉。
但是你这个操，我说你干我不太帅。
不带的话，因为我知道我额头很大，但是我不带的话是这样。没有故意，不是故意的，因为我想清爽。
这样额头大的话，说不会。
太会。
真的。我要跟你搞好关系。
对。我就觉得的话搞得很不舒服。
我刚其实想跟老师展示我这个词汇变后来我就很你我看吗？对。然后他就在这样，现在真的你苦了，说实话我确实听了他俩。
我将副本给你们送。啊，对啊，我看到这个副本，啊，不错了。所以就是放了就不能再拿这个。
啊，也可以拿
也可以剪开再拿。
对，反正没什么概念。
可以无限拿。So let's see how well we're doing, and you have any question, then we can try to answer them. What is marginal effect? So marginal effect, as we said, is just how X changes lead to Y changes, right? So in the example that we have already, if linear regression, the marginal change is just the coefficient, right? So just let me explicitly write, right? So if you are simple linear regression, right? So we want to say if one change in X and one change in how many change in Y is beta, right? Suppose you increase X by 1, right? Y would change by beta, right? It's simple linear regression is easy. But when you have like when you have a term X here and then gamma X squared, right? Change in Y, change in X would depend on X, right? So you will be beta plus gamma X, 2 gamma X, right? Sorry, right? The calculus, right? And this marginal effect, right? Marginal means change in X and little change in Y, depend on X. So usually you would evaluate that at the mean, right? So you would do is you would evaluate X at X bar. Okay? So it's marginal effect at mean. So for the same if nonlinear, you have Logit or Probit, the same idea, right? At the mean, if you change your variable X by 1, how the probability change, how much that is, right? Of course, the number doesn't really matter anyway, because we just say larger or smaller, right? So usually you don't care too much about that, right? Because the coefficient itself, you don't care that much, right? Usually care about the Y you predict, right? Right? Maybe sometimes you care about the magnitude, but usually it's not, you're not super worried about that part. Especially for you be a main care as academic, we do paper, we do care. But as a you applying, you care about predict the Y, right? The beta itself doesn't really matter anyway, right? You just like the what the Y is something you care more. But sometimes you also care about the beta, right? I hope that makes sense. When you should read Probit logic, I told you R square, pseudo R square. Later we'll talk about that. Pseudo R square, we'll pick the right one. Okay. Usually, as I said, I told you there's usually no difference, right? So it's just really matter of taste or really matter of luck, right? So the question is similar to ask me, there's a beautiful girl there. You want to send her a red rose or white rose? Really depends. I don't know. I mean, maybe red, maybe white. I mean, just very similar effect, right? If she likes you, then doesn't really matter. If she don't like you, no matter what rose you send, is going to be not going to be useful. Right? Same idea here, right? That's usually if it works, it works. It doesn't work, right? So it doesn't really matter probably logic. Is it clear? I hope I explained. Okay. I mean, I'm not sure if I answer you, but the short answer is pseudo R square, right? Or other measure AIC, BIC, we will talk about that. But doesn't really matter, right? At the end of the day, it's horse racing, right? Which one to pick will be, it's matter of you would have a measure, right? Pseudo R square to tell you, all right? Can you open the aircon? I think we open now. Hopefully it's okay. Yeah, happy for you. A bit difficult. So the only thing that I think is a little bit difficult now is we didn't go into detail of telling you this, okay? And the main thing is like instead they are related non-linearly, okay? So because we jump the step, don't tell you how to estimate, okay? then just say, okay, there's a model there, and instead of OAS, we do a Logit, and that's what we say. Okay. And the reason that we can't do it because, well, to learn this, we have to talk about maximum likelihood estimate and other things to do how to estimate. That would be way beyond the scope of our class. And the behind the logic is like too complicated to work on. So we just, okay, whatever, just keep it what we have. Okay. I'm sorry that if you feel super difficult, but the only thing I want to say is we have the y is 0 or 1, then you can apply that. And I guess in most cases, you care it's not 0 or 1, so you shouldn't worry too much unless you would be worrying about 0 or 1. And I hope that's okay. And well, but if you really don't really follow, so either the two choices, either you tell me exactly where you can't follow, which I can try to answer, or you can ask TA so that I can know how to improve. Right? I know what's going on there. Right? Otherwise, I can't help. All right. So you tell me, this is, I understand. I mean, that sometimes if you don't know, you don't know where you don't know. But if you know where you don't know, then just explicitly tell me. But I try to emphasize what is the important part. And the important part is when y is 0, 1, okay, you have more than regression, the choice of doing a Logit and Probit. Okay, and they are better in the sense that your prediction is better, because when you have linear regression, the prediction can be beyond 1 or less than 1. But when I have Logit, I would focus on having always have 0 to 1, because the way the math is set. Okay, if you still don't know, you can look at the AI ChatGPT, what's probably a Logit, and tell you a lot. But I don't have time to go too much about that, because even the textbook, they just say, okay, there's a way to do it, hand waving. So I think it's okay to hand wave a little bit. So what did we do here? Look at compare the length function based on the Logit and Probit. Okay, so linear probability model actually just when the index gives you -1, you just take -1, you 0, 0, go 0, so this is a linear. Okay, and when Logit and Probit, they will fit in this way. Maybe I give you an example to show it is a better thing there. Okay. Maybe I will just skip this slide. Okay. Maybe I just jump to this one. I think that is the most useful technique there. R square. Okay. And because of the way that it behaves, you cannot do R square. We'll define what we call the pseudo R square, which is method R square, is 1 minus this over this. Okay. And if you remember, R square is what? 1 minus SST, SSE. Right? R square, if you remember the way we do, right? R square is what? R square is SSR over SST, right? If you remember. But SSR can be written as SST minus SSE, right? Because SSE plus SR is SST, right? So you can write 1 minus SSE over SST, right? Right? So now it's very similar, okay? Which we will define later. Okay. And SST is what? SST is you run the regression just to intercept. Model just intercept. Right? And SSC is the model that of your stuff. Right? Your model that left over, right? There's nothing not explained, right? So the same goes on here. Okay. I have later I'll define what the likelihood is, but something that calculate based on intercept, the useless model. Okay. And this guy is based on your model. Okay. So same as here. Something based on the useless model, something based on your model. Okay. So, and the key thing is why this is called pseudo R square is when pseudo R square is 0, the model is useless, as we said, right? Because the model is useless, that they're the same. Okay, we'll define what is this thing very soon. But if this thing is useful, then this guy is much larger than this guy is much smaller than this one, right? So that would be giving you 1. Okay, that we will give the same idea. So don't worry, very soon we'll talk about that. Okay. So let me define the likelihood. I guess that's the only thing is not defined is what L likelihood means. And let me go to the very end of the slide. What's a likelihood? So let me talk about this because otherwise you all don't understand what we're estimating. Okay. Now, this is a method in statistics. How do you estimate something? Okay. And suppose you're given a coin. Okay. Like this one. Okay. Maybe this is a coin, suppose. And the question is, how likely I just throw it? See, it go in this way. Okay. I want to estimate how likely that it end up in this way rather than that one, right? Rather than 四脚朝天 or this normal one, right? So there's a question. So of course, you're going to do is just do many experiment, right? Suppose we do each time the experiment head, this is head, right? This is head, this is tail. And the question would be, okay, each time given the P, you observe its head is probably P, right? You given 0, it minus P, right? So that would be, given the P, you observe how many Y you see will be this time this, right? And the question is, how do I get P on estimate P, right? But I know the data, Y, we repeat the observation, right? Whether you get head, tail, head, tail, head, tail, which is Y1 is, if head, Y1 is 1, right? If the second is tail, this is 0, a bunch of 0 and 1, right? So what I'm going to do is, under this model, right? I have a bunch of 0 and 1 with data, this unknown P, right? And this likelihood. If given this P, this is likelihood, right? So what I'm going to do is, I will try to find a P, which is something I want to know, to maximize the appearance based on data. Is that clear? So why, right? Because this is different from the probability. Probability would be, say, binomial or whatever you learn is, you give me the P, I want to know the Y, right? You calculate the probability. Now we reverse it. I want to find the best P that fit what is realized. Okay. And that is, given the data, how likely that the P is, right? Because you can imagine, simple thing is, if Y are all 1, say, you will say P is close to 1. It's like 1, right? Or P, if Y is very close to, most of them are 1, then we'll say P is 1, right? That will maximize that happen, right? Because if all of them are 1, this is all 0, right? and this all the p's, right? Then you want to make the p as big as possible, right? Then that means that that would p is equal to 1, right? If all y's observed are all close to 0, then you want to make 1 minus this p as small as possible, right? That's what represent, right? So the p represent how likely that your here things. So that's likelihood. Okay. So that is what we have, right? The length function, right, will be the probability that y equal to 1. Okay, follow the idea there, right? And then the likelihood is just to maximize this, right? You figure out what are the betas to maximize this thing. This is likelihood. Okay, it's how likely that things you can see. Okay, and all the time, over the time you take the log, the same thing would happen. Okay, so go back to here. Okay, okay. So that is right. This is how good the model, right, under your thing, and how good the model under L. All right. So if your model is useless, log of L should be same as log of L log, right? LCO is just the model with rubbish intercept, right? So they should be the same. If your model is useless, they're the same. So R squared will be 0, right? If your model is so good, right, it's a perfect, right? And what happened is what? The likelihood will be close to 1, right? Because remember, likelihood is multiply, right? Remember the formula here is multiply, right? It's close to 1, right? Then that log of 1 is be 0, right? So this one will be go to 0. So this thing unchanged, right? And this one go to 0 because log function is like this, right? The likelihood is the probability, right? So the log function is 1 is log L, log of L, right? You go to negative infinity to 0. You can draw a nice thing, right? Like this shape. The best case is 1 and actually 0, right? And this is 0, then it's the best case, right? Of course, it always way before that, right? Is that okay? Good. Is that okay? So anyway, this explains why you want the pseudo R square as large as possible, right? Because again, it's like the R square, right? You compare the benchmark intercept with your model, right? And R square is the thing is explained, the thing you didn't explain. But now we are different. We look at the likelihood that is intercept, and likelihood your model, right? How good is your model, right? Is that okay? Another measure is called deviance. Okay, is how good is your fit will be negative of log. Okay. Of course, this one is the smaller the better, right? Because remember, just to remind yourself, log of that is negative, right? So you are in this region, right? And you take -2, you just flip that guy, right? It'll be something like that, right? Is it not clear? Seems like you guys are not responding to the graph, but let me draw again. So let me draw here. Likelihood, this is 1. This is log likelihood, right? And it's always like this. Beyond 1 is not anything useful, right? Because you never go beyond 1 anyway, right? And this is log L, okay? And what is, this will be negative log L, which is mirror image, okay? And you multiply by 2, something like this, right? And as we said, likelihood to 1 means that it's very good, right? So the lower the number, the better. Is that okay? I hope that I explained now, but this is just simple math you learn in the high school or even elementary school, right? Is that okay? I think in the middle school you learn that, right? The log, take negative and multiply by 2 is like, the graph is like that, right? Smaller the better. Well, it is not a high power math, right? Not high tech anyway, right? So that's called deviance. This is also the measure that you can use compare different types of stuff, okay? And here we have something like what we call the AIC and BIC, which is very common to use in compare machine learning model as well, okay? And also the time series model, which we don't have time to cover. AIC and BIC are the thing that you would do, okay? And very simply, you can see the deviant is already here, right? Of course, the smaller the better again, right? And here is very simple. I don't want, because if you fit better model, right? The more variable there, the deviant will get smaller and smaller, right? You fit any, you add more column there, then the deviant will decrease, right? But we want to punish that, right? Same as the adjust R square. So here same, P is the complexity, is like the number of variable, okay? So you would punish that. P is the complexity, means number of variable in your regression. Okay, the more the AIC is larger, right? So just a trade-off of fit and complexity, right? And here we have another one is log n. So instead of 2 fixed number, it really depends on the size of the data, right? Because you want that if the data size is large, right? We don't want that much of the variable, right? We want to punish that. It's nonlinear. So the data set, right? You punish more. Smaller data set, you punish less. Okay. And these are the way that people have used. So you want AIC, BIC would be the as small as possible if you want. Okay. Okay. So there's another one that I think we should look at as well. Okay. It's called the B.B.A score and not loss. There are another measure. There are many measures you can see. And why I've covered all this, because all these things appear in your, I think in your, you have to, log likelihood is there. Okay. And you have the LL null is LL0, right? So you can 1 minus the ratio give you the 0 R square. Okay. And here the log loss is actually very similar. This one is basically MSE, right? Right? It's the y minus y log square, right? Over n, right? This is basically mean square error, right? More or less, right? Just depend on divided by n or n minus 1, right? This is MSE, right? You just look at what you predict and what the data is and square, right? The same as MSE. Okay. And here is what we call the log loss. Also, later you look at is, in particular, is useful when you talk about the when y is 0 to 1, you were using this very weird shape of function. Well, I don't think you can make sense of that, but there is some math foundation behind this. Is called log loss. I'm not going to explain why this is the case, but there's a function that you can look at. Okay. And again, the smaller the better. Okay. And this is how you can do the real score, right? You want to prop it, you predict the result, you take a subtraction and square it and look at the mean, will be the function score. Okay. Okay. So you can see, okay, for linear probability model, you can calculate R square. The real score actually is MSE, right? And the stock square, you can't do it. You can do the log loss. And Logit and Probit, right? As I argue already, these two, you can't really make a difference, in fact, right? Because they're very so similar, right? Just same as the red rose and the white rose story. They're similar. So it doesn't really say anything. But you do see they're different, right? So which one you pick? R square. As we said, R square is not the best thing you to do, but you can look at the Bruce score and the log loss. Okay. And we say smaller the better, right? So probably you will pick Logit and Probit, but the difference so small, I would use probability model, right? Because interpretation is easier, right? The beta coefficients are meaningful, right? Much easier to interpret. So the idea is, in general, if this Probit Logit advanced model don't improve the model a lot, we use a simpler model. So the overreaching guy is actually same as what we call the Occam's principle, right? It's just like 奥姆剃刀理论, right? Occam's razor principle, right? If something is easier, then you should use the easier one, right? Don't think it so complicated. Okay. So it just, if I were you, I mean, I would use the linear probability model. Okay. So here is what we call diagnostic. Again, you want to look at how fit is a model, right? Because once you want the regression, you look at the model, and then you can try to see whether the model is nice. Okay. And here is what we call the calibration plot. Okay. But I try to go so okay. So here I do is Logit. Here I generate a random data, which you can forget because you can use the real data. But anyway, there's a data there I generate using the MP random, but you can forget about this slide because it's not important here. The important here is I run the Logit and as a result there, okay? And I use this method to digitize and look at multiple beans, okay? And look at the average of beans, okay? And I look at what the predicted and what is generated from the data, okay? And here I can generate the data based on the prediction and under the real result. Why I want to do that, okay? Let's see the example why I want to do the calibration, okay? And again, you want things in 45-degree line, right? Because this is same as the y-hat y plot we have seen, right? Is the probability, right? Because this is what is actually happen and what's predict, right? Same as the y-hat plot, right? But this is the probability level, right? So you want to say this is going to good if it's on this 45-degree line, right? If not, then it's the worst, right? So the main idea is like the following, right? Based on the model, right? You would say, what's the percentage people actually get healthy, right? And the model predict this one, right? So usually I want this is to be 45-degree line. If yes, the model is good. Okay, so I hope the same as the y hat y plot. But usually we don't go too much in details on it. Okay. So I know there are a lot. So let me summarize, because I think that is this is the first class. I just don't go into very detail because I think this chapter is not super important. But I want to cover it because later we use Probit and Logit when you do machine learning. That's something we have to mention there. And also there are some criteria. So this chapter, I more or less just try to introduce some term and then try to make sure that you understand what's going on there. So just repeat what we're doing quickly. Regression would apply in our framework. The only difference is why now is only have 0 and 1, whether they are healthy or not, they like spicy food or not, right? So that is a question, right? So as we have seen, we can do linear regression, that's no problem. And as we try to argue you that unless your model deliver very different from Probit and Logit, you should use this one. Okay, always use easier model whenever possible. Right? Don't go complicated. Okay. If it work, it continue to work. Don't bother. Why bother? Okay. So this example or looking about the health data. Okay. I'm not going to give you that one. Okay. And here is okay. We try to say the probability, right? Is modeled by this function, right? It's a CDF function there, right? And that will ensure that it's between 0 to 1, right? What does that mean here? Let me try to explain a little bit further, because some of you so we learned that probably you know the bell curve, right? This is the bell, right? Normal bell, right? Normal bell. This is the f function, right? The density function, right? But you know that we can figure out that the big F, right, is coming from the area on the left-hand side, right? If this X is here, the F is give you the area, we give the height, give you the height, right? So you know the big F would be somewhat like that, right? The graph look like this, right? And it must be at most is 1, right? This is up to 1 here. This is at this 0, right? So this would, no matter what value we have, it's going to be 0 to 1. So that's why how the Probit logic the same graph, but very similar graph. So why you can convert something nonlinear, right? It's saying that I have bunch of coefficient, right? Beta, X, alpha, gamma, Z, or whatever, omega, A, whatever, there are many things, right? You are going to say this thing will tell me where in this one, and I will go back and look at whether 0 or 1, right? So basically this one will tell me where is in the line, right? Maybe this number tell me I'm here, right? This number give it this here, and I'll go to this line, this give me the probability, right? By using this method, it's always from 0 to 1, right? Because the vertical is always 0 to 1. And this can be anything, right? You can map to positive infinity to negative any number. You give me this thing, I'll do this, right? So what it's going to do is my data, right? Remember my data are what? My data are all CO1, right? So my data is either here or here, right? Maybe this data have some particular X, Z, and A, and this one has A, and then I try to figure out what is the best alpha, beta, gamma, omega, such that I try to convert this to somewhere here, and I go back to that one. The difference is smallest, the best fit. Right? Is that clear? Right? Because is that okay? Right? Because normal has two things, right? Mu and sigma square. All right. So that means that I changed mu and sigma square. I would change the shape of the red one, right? And I also have this alpha, beta, gamma, right? There's two things to mesh, right? So more thing to maximize. But anyway, you are changing this, and this and that, right? To make you best fit. Okay. In simple regression, you just fit this guy, right? But now we have more thing to work on. So there's a likelihood thing goes on there, right? We figure out this best likelihood is have to figure out what is the mu and the sigma, right? Together with all this crazy thing and estimate. Okay. So you can see it's nonlinear, right? So the marginal effect is you change X, right? And you change beta by, right? And then you can move a little bit here, then you map out there. Is that clear, right? Because marginal effect of X will be, say you increase X, right? The beta will move up by 1, right? The Y will go by 1, and then this move a little bit, right? And the prediction will move to here, all right? Something like that. Is that clear what we're doing? So that's marginal effect is in this idea, okay? I don't want to go to the math because if you go to math, we'll take you a few classes, so we can't really go to every single detail. But because I guess most of you have learned undergrad, right? I mean, I can see many people looking at the slides. The old notes are so complicated. So I'm teaching something very simple to you guys. But do let me know if I'm teaching too easy, because I can always go crazy, right? There's no problem to going more difficult, right? So that is the YP here, the probability, right? So this is the case. Now what left is all these things we know, and then this is important because as the model is come from the Python, right? Just SM doc Probit or Logit, right? Compared to ORS, right? Just to remind you again, the code is only this guy, right? The Probit before it's ORS. Okay, just to remind you, there's nothing very deep here. And the thing is, you want to know how to use it because a manager, right? You don't worry about the regression, right? Because you have a staff who know regression, right? Which is Python, right? This one, you can ask the Python to do whatever you can do, right? So the only thing is you know how to use it. So the first thing that's using the pseudo R square, right? That's a method, right? You have seen the table there, but I explained to you why this is the case, right? And the other one is deviance, right? It's -2 log likelihood. Okay, the smaller the better. That's the name deviance, deviation from the optimal. Okay, and we have the two most commonly used method when we have a elaborate model is AIC and BIC. Okay, when we run regression, we don't do that, but actually can calculate that as well, but we don't bother. Okay, and this is how you would do the estimate, right? So deviant, right, is how fit the model is, plus minus, subtract from the complexity of the model, right? That is actually pseudo R square. If you remember, the pseudo R square do something similar, right? It's the thing very similar to how fit the model is, but if you have higher K, right, this is getting smaller, right? And this get bigger, you subtract a larger number, right? So increasing in the complexity model. So you can see K actually is a P there, right? But I don't know why I have K and P, but anyway, why PK, I don't know, no idea. I just follow the book. Why I have different notation, I don't know. Maybe I'm wrong, but anyway, this is what the complexity means, is how big the model is, right? It's a number of parameter, the model. But anyway, the computer gives you automatically, so don't worry about that. I mean, I just want to tell you what is behind, right? Of course, you can use ChatGPT to figure out what it is, but try to see lower the better. And also there's a 2 score there. These two, you often see when data we see machine learning method. Right? For prediction method, it's very useful, right? Because this is almost MSE, right? Because this is the difference square, right? Over 1 over n, right? MSE is it will be n minus k minus 1 or minus 2, depends on how we define it. If you remember the MSE, we define, where is my MSE? It's in topic 4. So the topic 4, we define the MSE is very similar model. You still recall the MSE? The MSE, what the value must predict over n, but it's n minus 2 here. Okay. But in general, it's n minus k minus 1. Okay. But that would be very similar thing, right? We don't need to worry about minus k or this minus stuff. Okay. And here, log loss is slightly difficult to explain, but you just take, this is given. Okay, I'm not going to explain. There are too many measures you can do. It's like related to entropy, but I don't want to bother. Okay. Just something, and then it's a less the better. I don't want to explain because it's a, if I explain that, it will involve much more difficult point. Okay, and here I have a y hat y plot as well. It just I want that to be closer to 45-degree line. The closer the better. Okay, so this is another way to graphically see how well the model fit. Okay, so I hope I kind of answered the question. Okay, and why do you want to do that? Because pseudo R square is not the only way, the best, right? So R square, look at the overall fit, and this divide the data into 10 bin and try to see the fit, right? So but to be honest, I rarely see this in the practice. Okay, graphically, people just argue the BIC, AIC, log loss, the score. This is the only thing that people see. But if you wanted to demonstrate your model is so nice, this is one way to do it. The y hat y plot is also I don't see very often, but you can do it. Okay, so as I said, we will skip this time series. So after the break, we'll go to the next lesson. Okay, so I know a little bit fast, but I guess because of the Probit logic is not something the main concern, so I just skip a little bit, go faster. So I go slower back after the break when we go to the next thing, right? The next thing we are on thing is, I think is the slide of 7, which I think we have much more interesting thing to say. So we'll do prediction analysis. So I think that would be more fun. I'll slow down a little bit back. So don't worry. I mean, just lost a little bit. Because, well, we can't spend the same time on everything, right? Something have to be faster, something slower. But in case you still confused or worry, just talk to me during the break. I'll see if I can help you to ease your concern. But anyway, you're always welcome to talk to our TA so that you have a better idea. Okay?
那种那种就看历史就行，无所谓。现在好像蛮纠结的，那个主要我想做那两个那个包附件，像就是有很多，然后那个
So feel free to fill in. I think I forgot then the last thing I forgot to go to the anything you can share. I mean, I'll go over that after the break. So someone said, you go to Macau last week. Yeah, I think there's a concert, maybe a singer, right? Yeah, I think I saw him everywhere in the Macau. Why do I apply statistics in gambling? Well, you can actually go to the stock market. That's how you do, right? I apply. That's why I don't do gambling, because I know gambling is unfair bet, right? That's I don't bet. That's win, right? So that's why I go to casino. What I do is to get free iced lemon tea and free cake. Then I win, right? By not betting, I win, right? Because of the fact. And do look that people go to the casino. I can do see that a lot of people. Some table have a lot of people. Some people no people. Do you know why? Why? And why? So you have 100 tables. You will see, okay, one table we have so many people. It's like everyone is on the table. See, one table has no people. Okay, do you know why? No, because it's by Zalo, right? By Zalo, it actually has more like luck, right? There's no skills, right? The guy who just serving you has nothing to do with that guy usually. So why? Think why? I'll talk about that after the break, but that would be something with statistics. Two fish in a tank, one fish in the other. Do you know how to drive this thing? Okay, that's fun. It's a good joke. I want to know where do you come from? My hometown is Hong Kong. Actually, I was born in Hong Kong. And if you say what happened to my great grandfather, right? My grandfather is also here, and my great grandfather is also here as well. But you probably ask, my great grandfather is where? I think it's some part of it is like in Guangdong, and that's my father's side, and my great from my mother will be I think it's somewhere in Dongbei, right? It's somewhere the people with the Manchuria, right? The Qingqiao, let's say. Then they fight from the north side to the very south, and then that is part of my mother. So my father is like, I don't know, that's always in the Guangdong for many years. That's why I know. I mean, I don't know too much because I'm not the one who studied history of my family, so I don't know. Do I believe alien in this world? This world means this earth, I guess, right? Yeah, I do. Yeah, I do believe there's alien. The probability that we don't have alien is almost close to zero, I would say, because we have billion of stars, and I think we do have alien. Okay, and I do believe some of them are alien, right? So actually, Elon Musk, I think he's an alien. He admit that he said he's alien. So I think he's an alien, but okay. So sleepy. I'll explain this a little bit after the break, okay? About the statistics. So please fill in this one if you have time. Oh, okay.
就算那就是现在的话，那他是我要去演，那你知道他们那个。 特朗普不会营销，我觉得他的码数真的很大，码数也超过营销了，现在这是这个世界上最大的两个网红。
对，真的是我俩网红。其实，那我其实一直在想，
对啊，其实马斯克真的是，主要是这个他主要是他关联了很多利益，所以他更新了，他有很多股票，他一言一行其实真的他现在都可以这么靠谱都没有，对，我觉得还是，对，我觉得很厉害。对，虽然他在推特上面随便发一个，他在可以影响股价嘛，都很不错。他当时不是还卖特斯拉股票，他如果卖的话，特斯拉可能股票会跌。他的那个我现在在交税，然后应该想帮我看要不要卖点特斯拉股票交点税，这样太搞笑了。对，他是当时怎么联系？我看过老高，对，他说的，老高说的，不是我说的。虽然我也想，就是那个时候，他先变成了哪个？但是当变成就是那非常比较，但是一直没有特别大的那个突破了。他其实不是有什么，也是那个数据就是他在全力就是这样再转一个，然后就跟踪，会开场的这个，有很多例子，有可能。然后就相当于固定，然后现在这个有技术做。对，他对这部分会有注意的，记者也会定期开始看。对，而且中国真的蛮富的，中国文化很多产业链，还是很成熟的，对，在做的话上是，像别的工作的话，你这个软件的造诣，我觉得还有点像，对。嗯，我就行动力去。
我等一下发出去。
没发吗？我再放一下。
你想是发一个手机失败，
放一下。
让打出手的，我不听，他就要开始台。
提醒是前面有
他发消费才这样，后面卖掉。
可以看的差不多。
好像也是老高的，应该也是老高的。
好像说负点。
我俩是一起的，
跟我说是。
对，
我们俩在一起。
对。因为啥？
少注一点。
当时也回今天看完，大家都没。
没问题的，
都
没什么区别。你翻这个。
你之前看吗？对，
不要，就是下饭的时候，不要吃饭呀。
但现在不怎么看，现在给他讲的是教学的东西，玄学，他讲好多玄学的，对，我感觉我没有兴趣，而且他现在更新的比较少，对。对他说他现在新加坡嘛，他说有工作，找的工作，然后有没有去优秀的工作？我想，他优秀这个多少粉丝，他有做本职工作做啥？他能赚那么多钱，肯定很厉害。
应该是 YouTube。
我现在很在一好像是大陆的，他上面还没找当时看也是的，都500-600万，还是
他绝对是恐怖的。
对很厉害，对，这你看，他的 A 里面有关律师台湾的 A 他是那个就是几十万的东西，他到100万都是身边都在台湾做，我听那个姐妹，他说好久，他说100万，他老高涨400万的，对，超夸张，我不知道他那个到时候我没东西。
但是确实，我说实在的，没有人觉得
对，我看了最早，但也看最长，我看18年就开始看，以前很早，他就开始做游戏，但是做游戏没人看，把老婆拉过来听讲故事，
果然还是得美女出镜啊，没有美女就是。
老婆好像挺有钱的，好像他们家之前老高都从他这样的，用过这个是车要把他老婆买，他老婆老高在日本工作，他老婆是做房地产，当时一个在日本创业，对啊，我就感觉他保养的很好，他挺厉害的，不知道家庭里。但是有上面的东西跟上管理。对啊，我的上面的1年级的课程。肯定是老师的问题，肯定是以前老师的问题，这是我智障老师的问题。我现在懂。这个年纪的话，这个可以不要。
我觉得不是啊，因为我还没有写过那个。对，如果算了，他一定要求
LPM 的话有这个效应的小学一样，因为它是一次连麦到10到6天，他们要真的上好没出来，他直接跑这边。对对。因为他本来是 YP 的这个现在那边就把它反过来，我觉得我还是有点现在把那个藏起来，不过那个 AI 那个上面，我觉得跟它上实际上不一样的，所以这样对啊，
我觉得不太对劲了。
怎么说呢？其实我觉得最近倒是蛮多，我不觉得最近，但是你还是 PPT 上不一样，我觉得还是在 PPT 上不一样。因为我看了他之前觉得他上面有扣的，远离的时候，然后我打开他扣了，我发现他有的扣也会有这个，这个老师他外面搞不到那个LPM 的感觉。一般来说，不过他这样都显示出来，但是那没问题，这个只是可以，就是说他，对啊，
我是觉得这一次就是建议你怎么样的。
对，真的。数据是很正常的，
而且他也不应该有会上对不对？
对，你这是 normal 对，你就是这个嘛，我觉得是这个，感觉更强势，啊，这个确实，哎，那你下面这个课，大厂，
这专业不一样，
就是会有一点点细微的，
对，就超了会有不一样。
就正常他做逻辑，其实扣的都没什么，主要就是这些细节。
对，我也是。
其他都没什么，对对对。
有点是比入级的多。
对啊，就是小一个 filter，这个帮忙，包括这个帮忙，这个多。我当时
每一行都
我当时做图讲就这样，我就在搞笑，然后对面因为太搞笑了，这个飞步都太详细了，这个很搞，这个很搞笑，对啊，这个很搞笑。
我就是买
12就没办法，12只能用 AI。
18多了多少？
哦，我记得过年。
上次我看讲座地方有讲那个讲座那个有个可以他那个课程，他说这个老他说就教老师嘛，然后他说真的想教会，但是我都没有看这老师自己在念
就是主要我们学会写中国就是他的也不需要，所以我们就什么都没有。老师上课就是之前的有配音的一些中国人最傻的，就是应该真的是这种难点的，就是也不停下来给你详细解释。这样的哦，是这样。
你学的太像了，你学的也太像了。我数学原理是吧？我上课都没有都自己写，好数学不停的浪费。我没有自己看别人。
其实很多是不少讲，因为我们副本的话根本不用讲。
对，他这个确实，他因为他讲的这东西基本上。有个东西不管它正不正的，它的频率是一样的，对，它频率是一样的，数也是一样的。
加油，应该还在的。
对，然后他反正就对，一直讲，然后有什么还有传统，还有传统。对啊，那真是太多了。对，然后就。
So let's see. I think we go back to the comment last one. So I just go back to the question I posed before the break is, you will see in the casino table in Macau, some table will always suddenly have so many people there. Okay, and some table actually and 0 people. Okay, and the reason is being that people believe in luck. And if that table actually you can win the bank, you can win the casino a lot of time, then people just flock to it thinking that the casino is weak or some size luck, right? If you want to play and then it's likely that one side always win, then you just bet on that one, continue to bet, right? Or you do all the contrarian strategy. You think that one side wins so much, right? Then it must be the case it's more likely to break, right? So you do that, right? Just like there's a lot of people like this. So that's why if the table, one side always win, then you will be a lot of people will try to go there. Okay, it's so many people there. I mean, you will notice. But that's I learned it. Right? I applied to gambling, right? But I told you there's always a sure win strategy, but I don't bother to try. I don't bother to do it. But I told you, right? Is you first the lowest bet I think now in casino is $500, right? You put $500 there, and if you win, then you go home, done. Okay. If not win, then you lose 500. Then you bet 1,000. Right? If you win $1,000. You lost 500. Right? You always will win. Now go home. Oh, don't continue. Okay, go home. And then if you lose, then you go do 2,000. Okay, and go so on and so forth. And the only thing you can lose is you run out of money, right? But if you win once, you go home. And usually the table, 500 table, the maximum is $2 million. Okay. I guess unless you are super unlucky, you bet 10 times, then you must win 1 time, right? I mean, if you're so unlucky, then I don't know how to say, but you bet 10 or 20 times, right? And then you still can make money, right? 500 and go home, right? Don't continue to bet. If you die this, then you can make some money, right? Out of that. That is always your win, right? But I guess I guess you don't, if you can follow that, it's okay, right? So let's see. What do you want for dinner? Oh, what do I eat for dinner? Usually I'm just free riding on my parents, so just they cook because my kids are taking care of my parents, so I just free ride, just normal veggie and normal fish and normal meat. Usually I eat a lot of veggie, surprisingly. I mean, I think I'm getting older, so I don't eat meat that often, but so that is a normal thing I do. Well, usually I eat for breakfast. I get in the morning and make some egg for my kids and egg some fruit. So that's the only thing I do. Egg and the fruit. I don't eat cereal or bread because getting older, carbohydrate will make me sleepy. So that's why I skip carbohydrate in the morning, whenever possible. So I just fruit and egg, and that's it. Because I make the egg for the kids, so that's why I already egg is a very good thing. Egg has a lot of nutrients and easy to make and also very nice. Add some salt, little bit salt there. That's how I do. What is the format for group assignment? And we need a pre. Oh, I mean, you say the project, right? The project, yes. We will do a presentation, right? Because of business class, right? So we should do presentation, right? Because that's something that you should practice. And presentation, I think I mentioned that, right? At the end, how I do is, this is the list, right? I will look at how many people we have. I mean, 50 something, right? And then we have 3 hours of the presentation time, right? So we cut something, we only have like 150 minutes, right? And divided by how many people we have, like 50, 60. So everyone have 3 minutes, okay? So if we have group of 3, you have 9 minutes for you to present your main findings in a business. So we don't expect you speak a lot, right? It's like your report. I don't expect you speak like very long. You should be as quick as possible. Tell me upfront, what is your result? Why? And that's it, right? Maybe go to tell me, okay, you run the regression like this, okay? That's expect in the real world practice, right? Something like, okay, suppose I say this, right? If I want to create a 3-minute talk using this example we just had, right? So I want to study how people stay healthy together with the smoke, right? I figure out that, okay, people smoke have 6%, right? And then look at how education changes, and then I'm done, right? Then you tell me the data I'm looking at, and that's it, right? Don't spend too much time on telling me nonsense, right? Imagine just looking at your boss or client, don't have time, right? Everyone is very busy, right? Don't spend your time doing a lot of stuff, right? So I guess that's an issue for students in China or in Asia in general, is the way we learn how to write things is we do a convoluted way, right? We don't do things in this way. We have go circle and circle and circle and go to the end, right? When we write passage, right? We usually write, oh, there's a lot of story, what I do at the end. Oh, what I learned lesson from this. Okay, I have to do this. I learned X, right? But you should revert doing the invert way. I learned X, here's Y. Okay, you don't go at the end, right? Very elaborated, okay, and do that, right? Just like, okay, the following, okay? In daily life, suppose I saw a beautiful girl there, I want to know her. So what I'm gonna do is maybe I bring a flower, I bring some gifts, right? I want to pretend I'm not interested in her, but just try to talk to her. And at the end, after some talk, small talk, okay, can I have your phone number? Right? And then just go on and pretend not interested in her, but just trying to do something else. And then okay, right? That's the way to do, right? You don't do this, go there. I like you, give me your phone number, right? You don't do that, right? But you have to do that in business. Tell me exactly what you want, and then you explain. Okay, so that is the idea. That's why I make it very short. Okay, and this is the business style. And that's different from the style you learn from other way, right? You tell me exactly what we want and go and elaborate. Just like how you write sentence in English passage, right? Your topic sentence, and you explain the thing in subsequent sentence in the paragraph, where you highlight what you want to say and then go. Same as the presentation here. Same as a report. I expect to see the very important thing at the beginning. That's why we executive summary at the beginning, right? So I hope that helps. Let's go here. Yeah, I think we have here Logit and Probit, so that's right. The speed is okay so far. Oh, so people in the north is more humorous? Okay, I didn't know that. I thought people in the north are more violent, right? Just beat his wife and I don't know that. Maybe I have genes, I don't know, who knows? Because now the gene is so complicated, everyone are the same, right? Maybe 300 years ago, we are under the same parents, right? Who knows? Would be same family, right? 300年前都是一家, right? Who knows? It turned out to be the case because, well, surprisingly, look at history. Indeed, this is true. And only during the common days, people survive, have offspring. You look at the old days, actually, only the rich and the noblemen can have offspring, right? And you look at Chinese, right? They said, look at your last toe. Okay, I think they study. So look at your foot. The foot. Look at this guy, the nail, right? Maybe too big, right? Anyway, and they said if this is divided, okay, it's actually come from Genghis Khan, 成吉思汗. So everyone, if your foot is like that, and then I think majority of people is like this, Han is actually the gene come from him. So that is discovery. And actually, you look at the gene similarity, look at that is most people actually follow similar ancestor, surprisingly. Only the winner leave the DNA, all the guy are killed. Anyway, probably too bad to say this, but so we are maybe very similar in the end. Anyway. So let's continue back. Okay. So I will slow down, as I said. I mean, because we passed through the thing that is we are going to get to something important. So I slow down a little bit. Okay. So we do prediction and do a LISO. Okay. So for prediction, now we want to care is give me X, I want to predict Y. Okay. And X have many names. You can see inputs, covariate, feature, or independent variable. When you see feature, is sometimes you will see in the machine learning. Okay. And Y will be the response, is also in the machine learning. This dependent or independent is more like regression. Okay. So these are the names. And I want to use X to predict Y. Okay. Using data, I want to predict Y. Okay. And it's a model-based idea. Okay. And so there are two types of data. It's called original data. The other is live data. Okay. Original data is the one that I try to build a model with. Okay. And live data is there's no target observation. There's no Y. Okay. And this one has Y. Okay. So later you will see what we mean by that, but okay. So there were 3 motivating cases for this chapter. We have 3 different cases. A, B, and C, but we only cover A in our class. So this one is I want to sell car, okay, and what price I want to sell, prediction, right? There's no data in there, okay. And what they do is look at the ad, okay, on the website and see what cars at what price, okay, because car has different characteristics. Okay, I want to say what price I should charge, right, for a particular car there based on the model. I want to put the price that I can sell easily, right? Not too high, not too low. Okay. And here we have two other examples that in the textbook you can look at that, but we only focus on the first one. Okay. So the other one is you run Airbnb. What price do you do it? Okay. So that's a hotel data. And the last one is the bank want to give loan, right? And which loan you should, which firm you should extend loan to, right? So that would be the idea. Okay. So again, we have different type of prediction. You want to predict y, the value of y. That's a regression we are doing, right? You can point estimate, interval estimate, that's what we have done. The other one is we want to predict probability. That is what with a logic and Probit, right? That's given the probability there. And the other one that we don't have time to cover is called classification. Okay, actually you can do that. Your model gives you 1 or 0, right? Actually, with the logic on Probit, you can say if the probability more than 1/2, then use 1. Less than 1/2 is 0, then it's become classification, right? So I'm not interested in the model where you give me probability. I'm interested in actually at the end whether 0 or 1. Don't tell me probability. Tell me yes or no. Okay? And of course, you can convert anything from here to here, right? You can set a fraction. Maybe 0.5, you will see 1. More than 0.5 is 0, right? But there's a rule there in addition from here to here, right? You can set the threshold 0.6, 0.8, 0.9, 0.10, right? So you can jump from here to here. Okay? So that means that classification is a one step from probability, right? Because you estimate probability there, and then you can tell me that at what level you would jump up, right? Is that clear? And if we have time, we'll talk about that, but I guess we may not have time, but let's see if we have time. But the book, I don't think the book has, but the book doesn't have anyway. I don't think the book has, but that is the model, at least the thing we cover. So that is the first thing. It's called prediction error. We have seen that many times, right? The regression is minimizing this squared sum of square error, right? Remember, this model predict, this is our data. You square it, add them all up, right? That's how the OS being done, the regression, right? And the Probit logic do different way. We know why, because this is the way that estimation being done. Okay. So in general, you look at all the machine learning textbook, the very first chapter will tell you how to decompose this three thing. Okay. All the textbook will do this. Okay. They will say this thing can be decomposed into 3 different parts. Okay. And the first part is bias. Okay. It's called overfitting and underfitting, which we'll define later. And the second one is reducible error. Okay. You use a wrong model. Okay. If it's a wrong model, which can be done by using the right model. Okay. So this one can be done. And the last one is something that is the genuine error, which is no matter how best you can do, there's something you can't measure, there's something you can't control. Okay. Destiny, the fate, right? That's something you can't do. There's some error maybe from the sky, right? This is something happened and fails, right? Maybe there's a solar wind, right? That happened affecting the solar system, and the thing happened. I don't know. There's a thing happened, so you cannot avoid. Okay. So the square loss has very nice property. It's symmetric and convex, right? Symmetric means no matter more than or less than the same. Convex means the further away you punish more. Okay. So that is a very nice one, because you would tend to use the absolute value, but absolute value is not convex, right? Because it's linear, right? The blue one is the linear one. Okay. And the red one is asymmetric, right? So the higher is different from the lower one. So the one we use the green one. Okay. So the symmetric is a nice one, loss function. So we know this loss function already is the mean square error we mentioned. Okay. And we can calculate the root mean square error divided by 1 over n. So now we are able to decompose it, the MSE. Sorry, this is not MSE. This is MSE, sorry. The MSE, we decompose it into several parts, okay? So forget about it. By math, you can do something like this, okay? And the true model is like this, based on some unknown function plus some error. This right noise have mean 0, variance sigma square, okay? And the estimate is based on y hat is like this, okay? So if you do that, you can decompose it into 3 different parts, okay? And the error, which is non-reducible, is due to this term, right? Which is no matter how the best you can do, there's something you can control. Okay, it's epsilon, which is given sigma square error. And the bias, right, is coming from what you predict to the mean of this value. It's called the bias. And this guy, with the mean, is the prediction variance. Okay, it's things that you want to measure. Right? As I said, if you pick the right model, right, this one, remember, this thing can be done, right? Can be avoided. If you're wrong model, then this one will be much larger. Okay, so that is the 3 thing there. Okay. Now I think we can talk about let me see the date. It's the old slide or new slide. Oh, I see the reason. I'm sorry, I update the later version there because I think I forgot the this old version. I should upload the version that I have Python code. But anyway, I'll upload the one later. But don't worry, bear with me. I'll upload the code later. Sorry. Okay. So let's look at the result first. But you can execute your code after I put there. Okay. I will put that maybe tonight. After I go with the office, I'll put that there. So the code is the following. So as I said, this is the data from I think Chicago, a website. Look at how people sell second-hand car. Okay. The question is prediction model, right? Because I'm not interested in running regression. I just interested in my car, how much I sell. So the best fit is the best, right? I don't care whether because of this feature I sell this much. I don't care. There's no correlation, causality. I don't care. Okay, just the best fit. Okay, and the thing that the data you will see is how old the car is, how long it's been driven, and whether other feature of the car, right? And this kind of thing. Okay, I will put the code there that you can run. So far I didn't have code there, but so, and there are many variables there. So there's a how much mile you drive is a continuous number, and whether there's a feature of the car, okay, and it's dummy whether one I think a small car or big car, okay, and then whether there's a new car or old car, and the car has many cylinders, means how good is it, right? And this kind of thing. Sorry, I don't know car, but I don't drive at all, so I don't know. So don't ask me the car thing, okay? So, but anyway, so what they do is look at different type of model and see in prediction how they're well. So basically horse racing exercise, right? So we know that there are many ways to compare, but let's focus on this multiple regression, okay? And then let's see. So first one is just age, how old they are, and square. The second one, besides age, look at how far they drive, the odometer, and then look at whether the condition, whether the dealer car, right, and whether they have cylinder, and so on and so forth, right? The last one is interaction of age, okay? So sorry, I didn't show you the regression how we've done it, but I'll put that there. We can go over that next class, okay, if you want to. So you can see this model, right? The bunch of coefficient. There are no star there, but you don't really care because prediction model, right? For prediction model, you rarely care about whether coefficient are star or not star. You just care at the end where the R square or log loss is going to be great or not, right? You don't care about whether the p-value, those kind of things is not your concern because you care about prediction value, prediction power, right? So at the end of the day, so which one they pick, okay? I think they didn't show it here. They look at model 3, okay? The middle one, okay? And why they pick this one? I forgot, but I think they look at R squared to pick I think they will use R squared to pick the third one. And they predict the price is 6,000 based on the model, okay, which is nothing deep here, okay. And the important thing is to look at prediction, right? So the important point is not R square thing, but you look at the prediction interval. You will see model 1 tells you this number, 6,500. Model 3 takes you 6,000. Okay, and the important point, the point estimate is not important, right? 1 point, but rather you look at the interval, right? 80% or 95%. Okay, so obviously you have this very wide range. This is better, right? So probably this is better model because you want a much more accurate one. So that's why they picked the model 3. But of course, you can go more. Okay. And now the key is I want to pick the model that is good, right? And the problem is you don't want the model to be very complicated. Okay, because the more complicated model usually tend to fit better in the data you have. Okay. But if you run away from data, that's a problem. The problem is external validity, right? Because the model may fit very well, right, from the data, but may not apply elsewhere, right? So that is a little bit issue there. But we'll talk about that very soon, so don't worry about that. But that is a thing, okay? And actually, we can have the model. You will later see that if you try to fit the model in original data, look at this, the RMSE, okay? If you increase the complexity, basically model 1, model 2, model 3, model 4, model 5, then the MSE, of course, goes down, right? But if you use live data, okay, then you will see the fit actually not that good. So what do you mean by this live data? Usually what you do, later we will show you, is if you have a bunch of data, say 100 observation, so what you would do, you would only use 80% of data as your training data set. Okay, later we'll do the Python code, actually very simple, called the test train split. We split them out, train and split, train data and test data. Train is to train the model, then you test the remaining model. Okay, and then if you lose the training data, this is very nice. And if you try to fit the model using the remaining 20%, something will go on. Okay, so something, what do you mean by that? It means that in general, that's what the case is. You would use somewhere in the middle. This will be the best thing you would do. Right? So look at this one. This will be the best. Not this, the simplest one. Not the best one, the middle one. I don't know whether you know the story of Goldilocks. Have you ever learned Goldilocks? Okay. If you are from the US, that would be a very famous thing. Goldilocks is a girl who is very naughty. And his mother asked her never go to the forest. But she's so naughty, she go to the forest. And she go inside a house. And she saw 3 bowls of congee. One is very hot. The first one's very hot. The second one is very cold. The last one is warm. And then he go to second floor, right? There's finally 3 beds. One is very big, very hard. The second one's a mummy bear that is a little bit soft, too soft. The last one is just right. So Goldilocks means that not go extreme, not too hot, not too big, and not too small. The middle. Actually, same as what Chinese said, 中庸, the middle one. Okay, if you go talk to the West Goldilocks stories, like you don't go to extreme, not too big, not too small. The middle is just right. But that is a story. I don't know whether you read the story in the childhood. That there's my daughter liked me to read that to her every day. I mean, that one is when she was young. But same idea here. Don't go to too simple. Don't go to extreme. Somewhere in the middle is the best. Okay, so that is the model. We will go over the model Python next class. I don't know why I miss it. Okay. So as I said, the question is, we want to avoid this problem, right? We don't want to fit that much. Okay, because our MSE is the only look at how they fit, right? So that's why we learned last class. So last time we just learned before the break. All right. We don't use R square loss MSE, right? Because we use just R square. We run regression, right? We have AIC, BIC, that punishment for more parameter there, right? So this is the first thing. This is one way. As I said, another way is you divide data into 2 sets, training set or test sample, right? And you use the test sample, okay, to evaluate that we call validation. Okay, validate is to approve it. Okay. Now that is nothing new there, but I think the most important is called the K-fold validation. Okay, which we'll do Python next class, is the following. Okay, that is a little bit funny. Okay, requires some explanation. It's like this one. So here is what we call the K-fold validation. Okay, so we will implement Python next class. Don't worry. Okay, there's a code there. So what we're going to do is the following. So we have data set. This is the bar is data set. All right. So what we're going to do is we keep 20% of data, usually, as a test data. We fit the model based on the 80% of the data. We test it. We run the whatever regression. We run the Probit logic, whatever you like. Later you run machine learning model. Same. Once you do that, calculate MSE based on the red one. Right? And of course, you will calculate different model. There's a horse racing there where you do that. Okay? But the horse racing is based on this guy, the red one. Okay? Similarly, this is one-fold, right? This is what we call validation. But we don't just want to use this one. What we do is, instead of this, we will do here. Randomly pick this few guys. Okay? And we solve the model based on this one, and then test it here. And we do it for every model we do. Right? Same when we have set 3, do the same. Up to 5. This is 5 fold. And then for each model, we calculate average on the MSE. And then we compare this final average MSE. And this is how horse racing being done. Right? So basically, the first set is like, okay, you estimate the model and we do horse racing. Day 1. Day 2, you do that. Day 3, we do that. Day 4 and day 5, average them out is the competition result. Okay? And that is, we will implement that using the Python. Okay? And the main thing you will see later, you see the K-flow. This is we have what we call the, later you see is SK learning. Okay? Will be the machine learning package. Okay? And then we'll focus on K-fold, and we'll do cost validation score. Okay? And that we will do the calculation there. Okay? So don't worry, this is something we will do later, okay? And then based on AIC and BIC, this is data. And this code will work, but I will show you how to work on the car example next class, okay? Okay, here, go to here. So this is called the in-sample RMSE. This is based on the test data, okay? You can see based on this data, okay? Of course, we have more coefficient, right? It's more complex. The regression has more coefficient. R square for sure increase. RMSE for sure decrease, right? But look at BIC. You would not pick the last one, right? You either pick this one or that one, right? 3 and 4 is the fit, okay? So this is what we call direct method, right? We just use the BIC to select the model. So this is, I think this is what you learn in undergraduate. If you have learned, this is what you learn in undergraduate, the BIC, right? AIC or BIC, this is how you pick, right? And this is, or you also undergrad, right? The undergraduate level, you also pick this one. R square is not the best, right? If you use just R square, yes. But R square is not the best thing, right? And this is what we mentioned, the cost validation RMSE. All right. So this is the first round. This is model 1, 2, 3, 4 MSE. 2 round, 2, 1, 3, 1, 4, 4 rounds, right? And average like this, average. And this 2 looks the best, right? So you either use model 3 or 4 for your prediction, right? If you want to say, right? Not the better, the bad, right? Because you can see this is a, you draw it, it's like up, down, up again. Exactly the model, right? So if you use BIC, you use model 3, right? If 4 is very similar, and again, small sample, okay? Small, simple model, okay? Use the easier one, okay? The best, especially your sample is small, right? If the sample is big, like what you're doing at IT Manager, your million observation, billion observation, of course, you can build as complex as possible. That's no problem, right? And 1 minute, I think I'm okay to end earlier, right? Just I will start prepare the assignment too, which you know how to do regression. As I said, this time the assignment will be less hand holding. Okay, I will just give a more broader instruction what we do regression. Don't worry, what we're doing is asking you to copy the Python code we have done, change a little bit, and that will be the assignment. So don't worry, it's not something complicated. Okay, so I will prepare that and hopefully release it by the weekend. Okay, so I see you next week.